talk this morning about testing the Internet of Things, but I think it will become the Internet of Everything, and what will become ultimately just the Internet. Everything that you ever work on, everything that you ever touch, use, share, everything you own, potentially will be on the Internet. Now, if that's the case, the challenge of testing it is going to be kind of interesting. And I'm going to explain a little bit more about what the Internet of Everything is and will be. Okay? So my first question is kind of, how many people are working on the Internet of Things, the Internet of Everything? Is anyone working on this stuff? Anyone got to just wave your arm? Anybody? Okay, 5, 6, 7 people. Okay. So a year ago in the UK, I asked a question of 200 or 300 people, and nobody was working on it. Now it's about 20, 25 out of 200. You guys are already making progress here, so it's coming. I think it will affect everybody in the end. Eventually, we will all be working on the Internet of Everything, okay? And that's my thesis. Now, in order for that to happen, there has to be some changes in the way we do our job as testers. So I want to just explore some ideas which set out, that describe the changes that we have to think about in order to test perhaps 1,000 billion devices. And that's the scale of the whole job. Now, no one will be testing all 1,000 billion devices, but your contribution might well be tens of thousands, hundreds of thousands, or millions of devices. Okay? So let's kind of sketch out the program. By the way, I wanted to show a video, but the internet connection is too slow. I can't show it, but never mind. It would have been a fantastically exciting event because I would be showing a little robot I made last summer. And I had the robot on the floor in my study, and it's got like 3 wheels, and it's got a Raspberry Pi on it, and some software, it's running a web server, and so on and so forth. And on my left knee, okay, was a tablet with a website. So I'm kind of sat on a chair like this with a tablet, and with some buttons, pressing left, right, forwards, backwards, and the robot is moving. Now the exciting part of the whole thing was you get my left hairy leg, the full screen, you know. So you've been spared that shock and horror. So, but never mind, it's just a little robot. So what I want to talk about is the challenge of testing, okay? The challenge of the notion of this idea that we call the Internet of Everything. And I'll talk about test strategy and so on, and I think the most interesting part of it would be what is the future for us as testers. I should also say briefly that although I talk about testing all the time, I'm actually a developer. Okay, so I apologise right now for thinking and acting like a developer too often. Okay. The people who are making the most noise about the Internet of Things, the Internet of Everything, are companies like Cisco, Microsoft, Facebook, IBM. I read that IBM are investing $3 billion in the Internet of Things. This morning, before I came here, I'm sat in my hotel room upstairs, I learned that Google are releasing their contribution for the Internet of Things. I forget what the name of the product is. Did anyone notice that this morning? Google's announcement about their product for the IoT? I mean, to make your home intelligent? So now Google are in the game now. So how many billions of dollars are being invested in this? If that quantity of money is being invested by all those companies, Intel, HP, they are investing billions of dollars in this. They believe this is the future. So you can believe that it will affect you soon, later, but sometime. Okay? And that's why I think it's important, and that's why it's kind of my favourite research project right now. So if you look at the Internet and look at what the IoT, the IoE kind of stands for, it's terribly confusing. Okay? There are no standards which are established. There are standards in development, there are some out, but there is nothing established. Okay? It's still like Dodge City, which is like Rexwell now. It's a bit like everyone's carrying guns and killing each other. It's crazy, you know. It's not settled down. It's not stable. It'll take 5 or 10 years to stabilise. But the exciting thing right now is that the cost of entry into this business is so low. So my little robot, which I can't show you, but never mind, it cost me about $50, $60. Okay, that's everything. That's including a computer that's running a web service connected to the internet wirelessly. Okay, including some Python code, Apache, MySQL, this kind of stuff. It's all for a few dollars. So the cost of building a product that potentially is part of the Internet of Everything is less than $100, maybe less than $50. And in 5 years' time, it'll be $5. Now if that's the case, the tens of thousands of companies who are experimenting with these devices, these little gadgets that cost a few cents, some of them are going to create devices that change our world. 10,000 of them will create products that no one ever sees. They're rubbish. Okay? But some will succeed. You have to believe that. And they will succeed in a scale that no one has ever seen. We think at the moment of the number of mobile devices, mobile phones. It's about 1 phone per person on the planet. It's about 7 billion, something like that. The Internet of Things, the Internet of Everything, will be something like 700 billion, or 1,000 billion, or some crazy number like that. No one knows. No one really knows. But in your day-to-day life, there will be 10, 50, 100 devices connected to the internet in your home, in your flat. In your office, there will be tens of thousands. In your town, there will be millions, many millions maybe. In your country, maybe even billions. That's where it's going. How on earth do we think about testing this? Okay? How can we possibly do this? How can Paul stand up here and say, this is the way it's going to be? How can this one person, who's tinkered around with a little robot, $50 robot, how can they sort of say, this is the way of the future? Well, I'm just going to try, and you can make of it what you will. I make no apologies, it's wrong. Whatever I'm saying is wrong. It'll be different, okay? We can guarantee that. Okay, so one of the things that I also need to mention is it's not a technical problem. There are significant societal problems associated with this. Privacy and security, and who owns the data and controls that data and makes use of that data is something that governments, the laws don't exist yet. The lawmakers have to do a lot of work in a very short time to make this Internet of Things safe for its citizens. Now, part of that would be is if you live in a country with a government you trust, well, maybe it's going to be okay. But there's a whole notion of whether you trust your own government to be careful and look after its citizens. That's part of the challenge of this technological revolution. It's not just technology, okay? So this is a different game we're in, okay? I'm not going to stick very closely to my slides, I have to say, because it's one of these things that you write some slides and you think, I want to tell a different story, so I'm going to tell a slightly different story, but the message is the same. I should also say one last thing is that on our website, jarrettconsulting.com, there's on the papers sort of section, there are 3 articles, quite long articles I wrote late last year, earlier this year. I think it's about 40 pages worth. So it's quite a lot of content. So I'm trying to defend a substantial piece of work. No one seems to be talking about testing the Internet of Things except me. Or maybe there's 3 or 4 people now. But there are hundreds and thousands of people working on the Internet of Things. So it's kind of, come on guys, we need some more activity in this area. So, what can I do about talking about the strategy for testing the Internet of Everything? I can only paint a picture, that's all I can do. So I want to talk about the scope of what the IOE is. It's growing, okay? Obviously, it is growing. There are a vast number of devices involved, and mostly, these are sensors. These are little devices which measure temperature, air pressure, velocity, GPS kind of positioning. They measure things about our bodies, you know, the flow of blood in our bodies, our heart rate. They measure engine temperature, revolutions per second, anything you can think of that can be measured. There's a sensor available, and that sensor will probably cost 10 to 50 cents. There are going to be millions and millions and millions of these sensors. 90-something% of the devices will be sensors, which will cost less than $1, maybe 10 cents. Once these things really get going, they'll cost pennies, a few cents. Okay? I should also say there's a thing called smart dust. Has anyone heard of smart dust? Okay, so these are computers connected to the internet or a network that are the size of a grain of sugar. That's how small these things will be. How cheap will they be? They might cost $1,000 each today, but they'll be $1,000 for $1 in a few years' time. You know, you'll take a spoon of sugar and there's 1,000 computers. That's where it's going, okay? They will be everywhere. Now, so I'm painting a picture that's kind of exciting, but terrifying. Okay, is anyone terrified? Okay, I think we just need to pay attention to it, okay? There's going to be some fantastic devices created in the future, but they'll need testing. So I think we've got plenty of work to do. No shortage of work for testers. So the objects that I'm talking about will be, you know, your home, maybe even city, a whole city. So places like Barcelona are calling themselves a connected city. They are promoting themselves as a city of the future, as a smart city. And they offer the city itself, the infrastructure, as a test environment for entrepreneurs to test their new ideas, their devices, as long as they support, you know, better life in the city. Okay. The IOE at the moment looks like devices which are all standalone, but actually nothing is standalone anymore, is it? Nothing is completely isolated. So all these Internet of Things devices, the whole architecture, will be connecting to, you know, payment systems, government systems. You know, your business will be completely dominated by the devices in the network. Also, by the way, all these devices provide another entry point to hackers if they're connected to the corporate network. Interesting times are coming. So, you know, my argument, I was asked about a year ago, is it the Internet of Things or the Internet of Everything? Well, I went to the Mobile World Congress. Did anyone go to Barcelona, Mobile World Congress? Fantastic show, biggest show I've been, not as biggest on the world, but 92,000 people. So here we have, you know, some hundreds. Imagine a conference with 92,000 people. Terrifying. I know there are bigger ones in the States, of course there are, but it scared the hell out of me, you know. And what I learned there is that the word on the street is it's not the Internet of Things, it's the Internet of Everything. Okay? And actually what will happen is over the course of 3 years, the Internet of Everything will become just the Internet. But it will be 100 times bigger. Okay? That seems to be the story. So the test strategy for the Internet of Everything is literally the test strategy for everything. Now that's something to think about, I think. So is this the biggest thing in 30 years? I think it is. Okay, so I want to briefly give a bit of history and just try and suggest that actually, you know, to defend this statement. The continuous delivery, how many people are doing continuous delivery, DevOps? How many people have that as their part of their process? Oh, okay, got a few. Okay, good, thank you. The notion of bringing automation into our processes in a pervasive way is quite new. And by that I mean, what's happening, I think, out there to some degree, is we're moving testers left. There's a whole thing called shift left, which is beginning to gain more momentum. And you could say, well, we're getting rid of the test team. Ooh, bad. But what we're doing is putting the testers into the development team and asking them to collaborate and work very closely indeed, and to defend, what testing is about, if you like, and to do the testing early as possible, so that once the developer presses a button and says commit, all of the processes, and I mean every process after that, is automated into deployment and delivery. And you might not release software into production and share it with users, but it's in production. It's ready to go. Now that mechanism, that DevOps, continuous delivery kind of mechanism, it seems to me the only way the Internet of Things can be delivered. So it seems to me you'll deliver once in a systematic way, and then 95% of the life history will be in a continuous delivery, deployment, continuous change. And that can only mean one thing: lots of work for testers. But this is the way I look at it. It's not that the people are moving to the left. That's not what's happening. It's that the thinking required to assure the delivery of these systems is moving to the left. It's the brains that are moving. Maybe developers can do the testing if they think like testers. More likely, we'll have some people with the testing disciplines in the development teams and working in kind of a very close knit team. So, okay, we're on a journey that will increase the size of the Internet 100 times, perhaps, something like that. Where are we on this journey? I just want to give you a little bit of context as to how I think the testing job has changed. So I'm going to kind of read what I've got here. About 30 years ago, those of us who were in the software business were focusing mostly on green screens, text-based transactions on mainframes, mini computers. Fine. There was one way in, one way out. Every field had its own validation. It was kind of easy to test in some ways, although you had very, very many screens, hundreds, thousands of screens. Okay? It was a problem of scale, not really complexity in that regard. And then GUIs came along, where the Macintosh in '84 and Windows a year or two later, and suddenly there were many ways in, many ways out. Events, asynchronous to the way you think about your functionality, affected the behavior of your systems. You had little control over these outside events, so life became more complicated. Then we had client-server, and client-server really was a huge change, because the Internet is just an example of client-server. Client-server was the big change, not the Internet. All the Internet did was make it democratic, okay? Everybody could access it, which is significant, I know, but technically not a big change for testers. Client-server was the big deal for us. Now we have the mobile revolution, and can I just ask, how many people are working for a business that puts their software onto phones and mobile devices? How many people are in mobile? I didn't do anything. But it reminds me, I must drink. Water. So a few years ago, something called big data arrived on the scene, and then that was really fascinating to me, because the people who've been working on mainframes 30 years ago, they said, well, we've been doing big data since the 19-somethings, kind of. But big data was on everyone's agenda. So now big data, where does that come from? It comes from these mobile devices. Okay, so big data, mobile applications, these are part of the same thing, okay? Now we have this thing called the Internet of Everything, which is not well defined, except that we know there are going to be a lot more devices, mobile and fixed, okay? A lot more data, maybe 100 times more data. Most of these sensors, all they ever do, all day, 24 hours a day, 365 days a year, is they chirp like little birds. They go tweet, 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 and each little tweet is 20, 100 bytes of data. But they don't stop. Every second, every minute, every hour, whatever the period is, they do not stop. That data is going somewhere. It has to be stored somewhere. So the scale of data is what you think you have now is nothing compared with what there will be. I was told recently that a factory, a medium-sized factory, manufacturing business, would be collecting a terabyte of data. That's 1,000 gigabytes of data every day. That's kind of nothing like. I remember a long time ago, 30 years ago, I bought my first PC. It had a 10 megabyte drive. That was a big deal. Now where are we? It's 2 or 3 orders of magnitude greater. It's not the same business we were in 30 years ago. Just for one reason. So the Internet of Everything brings new levels of complexity and scale. Okay? It's a big deal. You have to believe that. And you have to then sort of say, well, because of this complexity, functional testing is now going to happen at large scale. Well, what the hell? We've got tools. Well, that's not a problem. The tools aren't the problem. We've got tools already. We need some more tools. We always need more technologies, of course. The problem won't be we need a tool to run our million tests. The problem will be we need a million tests. Now, how are we going to do that without technology? How many people do we need to hire to create 1 million executable tests? It's not going to happen, except by using technology. That's why I say continuous delivery, very high levels of automation are the only way to deliver the really, really big Internet of Things systems. If you want to test your home automation, maybe you don't need millions of tests. But if you're running a smart city, it will be billions of tests. And you are somewhere on that spectrum. And I'm sure automation is in there somewhere. Okay? So, okay. What does that say? HP Connection Manager is not happy. But do I care? One of the things I learned in Barcelona at the Mobile World Congress was that CMOs, Chief Marketing Officers, have more budget than IT in many organisations, in the mobile space at least. What does this mean? Have you ever worked for a marketeer? Does anyone work for marketing people? They are, with all respect to what they do, they are the craziest, most unreliable, most, what's the word? Just maddening stakeholders you can imagine. It's awful. They don't know what they want. They do know what they want every single day. But every day it's a little bit different. And that's the problem. So how are these CMOs going to get their way? They're going to say, we are going to have, in 100 days, 100 changes, 100 projects, 100 deployments, 100 full-scale test automation regimes, 100 whatever you like. I mean, forget the numbers, it doesn't matter, but the iterations are going to be extremely short. Another argument for saying we have to get into automation in a big way, in these worlds, in these new environments. Okay? So I should also say that part of that game would be, okay, we run our million tests, and they all pass. Fantastic, hooray. Not. They don't all pass. We're going to have to deal with hundreds of thousands of status reports with details of every single test, and we're going to have to be able to interpret the outcome of these tests from tools in much more sophisticated ways. We're going to have to get into visualizations that really, really help us to understand what's going on. It won't be, 3 or 4 bugs a day, 5 or 6 tests per day, or whatever the numbers are. It'll be hundreds of thousands of things in some environments. But expect to see tools that bring in much, much more sophisticated visualizations of the status of what we do. Without naming tools except Microsoft Excel, let us argue, Excel is the best test management tool on the planet. Okay? It does exactly what you want it to do. But it's limited. Okay? We need better than that. Okay? Developers will have better things than that, and we need to catch up. Okay, so with all that said, we're still at the start of the journey. So I want to talk about the scope of testing and try and, now I've set the scene and terrified you and excited you and who knows what, I want to talk about the scope of what we're talking about. And I'm just going to go through, if you like, a list of the kind of testing that we'll be getting involved in. So firstly, we'll have hardware level functionality. These 10-cent, 50-cent devices, well, they're tested by the manufacturer. We won't be testing those, okay? They're just components, we don't care. But once they are assembled into a package, you know, which is unique on the planet except to our company, we will be testing hardware at that level. And we will be drifting more into hardware testing than software testing at the lowest level, which is well understood. Well understood. But not many organisations outside the embedded system space really know how to do it properly. So we're going to have to learn about embedded systems at a low-level hardware and software functionality. There'll be integration and interactions at every level. So the little device, like the security alarm in your house, which flashes when you walk into the room, you know, which detects burglars or your children, okay? That is an object, let's call that an object, okay, in this hierarchy. That connects to a local hub in your house. That local hub in your house might will connect to your router or internet connection, of course, and it will talk to some server out there on the internet. It might be a local based in the town, or it might be a nationwide thing. In the UK, I think elsewhere in the world, the power delivery companies are installing smart meters. That makes sense, smart meters. So they measure the electricity, the water, the gas coming into your house. Partly it's to make economies for yourself, so you can monitor these things and use the energy more carefully. Partly it's for them to know exactly what you are using. There's integration at every level, that's the point. So it used to be a component, subsystem, system to system, you know, integration. We've probably got 2 or 3 more layers to worry about now. I'm not showing it today, but if you look at the paper, there's a 7-layer architecture I've suggested, okay? There are 7 layers, it's not 4. Collaboration confusion. What will happen in your car is that you will have a car which will tell you where the parking space is in town. The car will talk to the city network. The city network will say there's a space next to the hotel for your conference that you want to drive to and whatever. And then what will happen is other cars will learn about this and there'll be a competition. There'll be voting. There'll be kind of a democracy between the cars. The cars are a crowd. The cars are a democracy of themselves. And then some guy on a motorbike will go and take the space. And then all the cars will say, shit, what do I do now? And then, you know, what do we tell the driver? And the driver's there saying, ho, 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 I'm happy, driverless car, of course, you know. And then the car will get confused. And I think one of the sports that will emerge from the driverless cars, have you seen any in the country yet? Google are doing this, Apple, God help us if Apple get them going. Can you imagine a new sport with teenagers saying, look what happens when I jump in front of a Google car? You know? And then all the kids will go, look at me, look, and then someone will get killed. And then what happens? There is no law. You need laws to do that. So new sports will come along, where the people are competing with computers. And it's not at chess, it's at you know, dangerous sport, you know. Rather than throw yourself off a bridge with a big rubber band, whatever, you'll be jumping in front of cars or trams. You get the idea, okay. So collaboration confusion, that's a big deal. These systems are going to be constantly talking to each other. Our car, by the way, I'm sorry, I'll move on, yes. Did I do 2 slides? No. So testing at scale. If you're testing a smart city, you're testing an environment where there may be 1 million cars. There might be 50,000 vehicles owned by the local authority, you know, all the trash trucks, all the garbage trucks, all the dustbins, all the trash cans will have a chip in, which will say, I'm full, empty me. Apparently 1/3 of the money spent by our local governments is spent on collecting trash. So they are going to implement these systems. So your trash bin, whatever it's called, will notify the truck to come and empty it. Time is up. Okay, that's my half-hour time. I told you I was going to go longer than that. Each car has its own network. So we've heard of mobile networks, but mobile networks don't move, the devices move. We're going to have networks that move. We'll have chips in our bodies. We will become things on the internet. You know? There's a company in Sweden I saw, just look it up on Google. They're in this business. So they've asked all their employees to have a chip about the size of a piece of rice injected into their hand in this little soft part here. It's not that soft, it hurts. But it allows them to open doors and do stuff, you know. Personal and corporate privacy, I don't know. Is it the end of personal privacy? I don't know. But we have some serious problems to deal with. What else? Not all IoE systems will be large and complex, but we face a larger range of problems and challenges. That's the point. Even the small systems will have a lot of difficulties to overcome. Huge numbers of risks, huge numbers of new types of testing, huge numbers of combinations that we have to think of, we cannot ignore. So the risks of failure and our profile of our systems is changing. So this is the bit you've been waiting for, that I'm going to do in about 1 minute, okay? Read the paper, okay? Read the paper, that's the point, okay? So how are we going to do this? We are going to have to model our way out of this problem. We are going to have to use our brains supported by technology to get ourselves out of this problem. We're going to have to create very sophisticated models. We're going to have to use very sophisticated software to implement those models, and even more software to create the combinations and permutations and test cases to run and act upon those insights from the outcome of these tests. So developers have to change the way they build software to allow this testing to happen. Test environments, that's going to be a whole new can of worms. We're going to have to sort of ask a city to allow us to test our systems in that city, in that environment. Because these things move. They move along roads that do not shift. We can't invent data, we have to use data that makes sense. You know, whether we use Google Maps or whatever to get our base data, we have to use technologies that are not under our control to build our environments. The scale of testing will vary widely, but we'll go from the very small to the very, very huge. Tool support, I don't want to talk about this except to say we're going to need some of the tools we've got plus a lot more. Analytics, we're going to have to rely much more on data collected against tens of thousands or hundreds of thousands or millions of tests. That's the change that we have to, we have to become data scientists, not just testers, okay? If you like, the analytics code is like your sensor network. And so one of the things I'm beginning to say to people now is like, think of your DevOps processes. Those DevOps processes are things on the internet. They have sensors too. They have feelings too, don't they? Okay? Performance testing, yeah, as before. The future, very quickly. I talked all day yesterday, most of the day yesterday, about this new model, which I'm going to show you a picture. Here it is, look it up, it's on our website, etc. Okay? We have to think more carefully about the way we think in order to make these things happen. We can't rely on the good old, bad old ways, whatever those ways are. We have to change the way we think. This is a suggested way of understanding what we do and how we think. Manual versus automated, get ready to do a lot more automation. We have to work in that way. Manual testing is going to exist forever, of course, but the proportion of tests, the scale of testing is only going to happen through automation. It's just the way it's going to be. Shift left, watch out, it's going to come your way. Be ready for it. Welcome it. Move your thinking to the left. Don't worry about moving your job. Move your thinking. Right, close. Hurry. Testing the Internet of Everything is kind of the next step on our journey. Okay? And it's a big step, I think. Like client server, like the web, like mobile. It'll take 5 to 10 years to get going, to peak, and then we all understand what it's all about, and then something else will happen. Again, the tools we need don't yet exist. Okay? The technologies we need to build the IoE don't yet exist. It's still very early days, okay? Which is fantastic, because you can say whatever you like, and people will say, that's really impressive, but no one can challenge you. It's fantastic, lovely. The time will come. My argument is that testing in the lab and testing in the field, those relationships will change a little bit, and we have to change the way we think in order to make this work. That's my real point. Thank you, and I'm sorry to overrun.
Еще осталось 4 минуты, можно один вопрос. У кого есть вопрос? Нет, нет вопросов. Кто-то хочет задать вопрос? 3 минуты.
Hi, Paul. My name is Alexei, and I have one question, maybe statement. Do you hear about system in Singapore for traffic management?
I've heard of it. I don't know any detail, but I've heard of it. Yeah.
The interesting thing, there are already in Internet of Things, I think, because there are a lot of sensors in the city, and they can control all traffic in town using it.
Is it working?
I think yes, about maybe 50 years. And I really want to ask you, maybe you have any assumption or something like that about how they really test the system, because you need to build a whole lab to maybe mock the city, the cars in it, and all traffic lights and pedestrians.
Yeah. So one of the things I didn't have time to say, I'm sorry. I mean, I've condensed 2 days into 35 minutes, I'm sorry. One of the changes that's happening is, rather than think of testing, functional testing, as here's a screen, I test the screen, here's another screen, I test the screen. That's not the way to do it anymore. You cannot predict the expected results for the number of tests that we're talking about. So the way we test is going to have to change from a small amount of manual testing in that way to simulations. Rather than functional testing, we'll be doing simulations. We'll be saying, okay, we're going to get, today's test is 300,000 cars coming into the town of Minsk. God help you, okay? You know, if they all came at once. But that's the test. How do we do that? Do we do that by getting 300,000 cars, 300,000 people? We build a model. We build a model. We run a simulation, like a weather forecast. So our testing will be more like weather forecasting in some respects. We'll be looking at pictures all the damn time. What are our expected results? Okay, cars that start on a journey that should last 1 hour, arrive at their destination without a crash, without a major delay. They take valid routes through the city. They do not drive through buildings or through cars, or like a game, you know? And these are our expected results. Now, have we got the time to check every single outcome of every single test like this? No. We have to move away somewhat from what we don't understand as normal functional testing to simulations. It's almost like performance testing tools, with the tests not doing stupid stuff, but doing really intelligent stuff. So we need some really clever stuff. People do simulations now. It is very, very expensive. The weather forecasters, what is it? The weather forecasters use supercomputers, you know. Do you know that if you want to predict the weather, if you say the weather is the same tomorrow as today, you have a 70% chance of being correct. With the best supercomputers in the world, I'm going to be wrong here, but I think it's about 76%. With all that technology, we still can't get it right. I think that's the world we're moving to. We're going to have to work on trends and visualizations, and I don't know, not gut feel, but engineering house. You know, we're going to have to be a lot smarter in order for this to work, or it'll be chaos. Can you imagine, by the way, driverless cars in somewhere like Minsk? I think so, yes, yes. The roads are really quite empty, it's good. It's a really nice city to walk around in as a pedestrian. Have you been to Bangalore? Can you imagine driverless cars in there? No, not going to work. So it's not all perfect, you know. Anyway, I don't know if that answers, but whole cities are getting into these projects. I mentioned Barcelona, I think Singapore's another one. I'm sure there's some American towns getting into it. It's going to happen in your town soon. How am I doing for time?
Время закончилось. Ответьте на вопрос. Время кончилось, да? Дополнительными вопросами можно подойти к Полу и все задать.
One last thing. If I said I'd sign your little book, I'm happy to sign it, but don't all come at once.